Alaikum and good afternoon, everybody. I hope I'm audible to all. This is Ikra Akbar. I'm from SGS, Pakistan, and I hope and wish everybody is doing great today. We will start our session with the recitation of Holy Quran.
بسم الله الرحمن الرحيم.
In the name of Allah, the entirely merciful, the especially merciful.
قل هو الله أحد.
Say, He is Allah, who is one.
الله الصمد.
Allah, the eternal refuge.
لم يلد ولم يولد.
He neither begets nor is born.
ولم يكن له كفوا أحد.
Nor is there to him any equivalent.
All right, everybody. First of all, please allow me to welcome you and share my gratitude for everyone across the Middle East region, Pakistan, and other countries to join us for this much demanded webinar on revolutionizing asset integrity management, IMS software. Thank you very much for sending us your registrations and your questions. This session is going to be for 1 hour, and especially last 15 minutes is dedicated for QA session. Mr. Luiz is our speaker today. Thank you, Mr. Luiz. He joined us from CENOSCO. Ms. Chilena is with us. She's also from CENOSCO. And today your moderator is Mr. Saim Qazi. Over to you, Mr. Saim. Thank you.
Thank you, Ms. Ikra. Hello, everyone. So this is Qazi Saim Ahmed, and I'm from the SGS Pakistan, having more than 10 years of experience in asset integrity. And mostly I'm involved in the program starting from the scratch of development of RBA program, CCD, implementation of IOW, HAZOP, SAIL, and OPA. So as you know that today is the topic of our webinar will be the revolutionization of the asset integrity management to provide a digital solution to give a digital solution to your IMS and to your AIM system by means of our IMS software. So I'm very pleased that Mr. Luiz is with us, and after that he will give a brief presentation and conduct the webinar. Thank you, Mr. Luiz. You can start your presentation. Thank you.
Thank you, Saim. Let me share my screen again. Yeah, at the same time, I'm Luiz, here with CENOSCO in the Netherlands. I work for a software company, but I am a mechanical engineer by education, and I've actually made my career with SGS in Brazil, Canada, and the Netherlands. I've been involved with the RBI, inspection and integrity for now 20 years. So I'm going to give you an idea on how IMS can revolutionize your integrity management approach, not only for the mechanical perspective, but all the elements in a proper integrity management system. I like to start why we are here today. I think I always like to bring the importance of an integrity management system. There's different aspects to it. In the past, it has caused quite some catastrophic events. The one that comes to my head is the one from Union Carbide in India. That is one of the first catastrophic events that I got at school, and I kept learning about it. It fascinates me. The studies have been done, and what improved the level of security and safety in industrial assets, but it's not that old, right? So you see, if you had the chance to look at the Chernobyl documentary, and more recently the Deepwater Horizon, that caused a major environmental and economic damage to an oil and gas major. So it is still happening every day. So that's why I like to start saying, what is the importance of an integrity management system is really to prevent those from happening, preventing, and the industry should be there to care for people and not harm them. And also, of course, not forget the economic impact. What does IMS does? What is IMS is stands for an integrity management system, and it really here to address a couple of problems. I will cover in a minute which kind of disciplines we talk, which kind of equipment we talk, but in general, oil and gas, fertilizer, chemical industry, even pulp and paper, if you wish, they are high risk assets, which means if an equipment fail, the consequence will be quite high in terms of replacement value and environmental damage, people damage. So we're really looking at high risk assets. We cannot forget the unexpected maintenance. Unexpected maintenance is a bit more related to a reliability. Yeah, make sure that you're commercially viable. So you're producing the amount of product that you need to sell to survive economically. So we cannot really forget that element. Another key problem these days that I'll also cover that in a different framework is that decentralized data. The decentralized data is about having data scattered all over the place, in different systems, in different computers, in different people's head, and that makes it very difficult to make your asset compliant to regulation. And if you cannot even comply with regulation, or hard to comply with regulation, you can imagine that the decision process is also compromised if you don't have a reliable centralized data. And I'm going to cover that in a different framework as well. So those are, you can group with those three main problems a lot of issues that you might have, different products, different disciplines. You will group them in those three big blocks. What do we bring into the table is what we call a one IMS philosophy. One IMS means bringing together multiple disciplines. So I'm talking about using RBI data, correlate with RCM, with reliability-centered maintenance, bring your HAZOP, your LOPA, bring different disciplines into one system. And IMS as a solution isn't an out-of-the-box application. What does it mean, an out-of-the-box application? It means that it contains a methodology, it contains a set of libraries with degradation mechanism like failure rates, checklists, reports, dashboards, queries, a lot of those features that you need to start using this software as quick as possible. It will also include a guided prioritization, advanced calculation. So we will do corrosion calculation, corrosion prediction, predict a maintenance task. We're gonna, optimize your test intervals depending on the type of instrument you have. So the solution is quite comprehensive. Again, out of the box. The more out of the box you are, the easier it is to implement. The more seamless you're going to use all the features. Yeah, it doesn't mean that it's going to be a standalone. Yeah, you still can connect with the CMMS, but the solution comes with a set of processes and procedures and features to address those problems. The result, of course, a safe asset, no accident, maximize the asset availability, optimizing inspection cost. So when you're talking about inspection cost, I'm really talking about extending the inspection interval. The longer you have your inspection interval, the less you can spend in inspection. But you can also you should also only increase the interval if you have a good system to back you up, right? To allow you comply with regulations. So those are the main results. So if you have an IMS, an integrity management system, in which you have fully implemented for multiple disciplines, it will give you compliance, not only for the regulators that will come and audit and can give you a fine, but also for insurances. If you show to your insurance company that you're in control of your risks, yeah, that you understand your risks and you take appropriate actions to mitigate and control those risks, you also have a lower premium for your insurance. Yeah, your management will be happy, and so it will come as an overall result for your system. You know, less leaks, less failure, higher availability. Yeah, and optimized cost. Optimized cost. I'm not saying that you're going to reduce your costs immediately. You're going to optimize. Means you're going to spend more time on the high risk and less time on the lower risk. Okay. What is IMS? An integrity management system. There's a lot of background. So IMS has been out there, or the methodology in CENOSCO has been out there for over 20 years. So we've been evolving from a pure risk management solution that will only, calculate the risk or the criticality for a specific equipment towards an integrated management system. Yeah, so where you're going to cover multiple disciplines. We have been working since the beginning with Shell, Shell Global Solutions, which is a few blocks away from our office here in The Hague, and that partnership is still ongoing. The solution and the concept that I'm presenting here is being fully used by all the Shell assets globally. If you work for Shell and if you're still not using it, you're in the pipeline, and for sure you will be implemented very soon. In Pakistan, Shell in Pakistan is it's in the implementation stage for their tanks and terminals. So the module, so IMS is the platform, it's a one IMS. But we still have disciplines, right? So you still have your mechanical integrity team that looks at NDT and inspection. You have your maintenance that look at preventive maintenance. You're going to have your instrumentation team, your electrical, your safety instrumentation, your civil engineering team. Those are disciplines. They will have different flavors. They will have different needs to use a system like IMS. So IMS has developed a set of features and functionalities for the different disciplines. And those disciplines are what we call pressure equipment integrity. Here we're looking at an RBI approach with corrosion calculation, with the degradation management. Okay? That's the PI module. We go for RCM, where we can look at electrical equipment, instrumentation, rotating. Traditionally, there's been a lot of rotating equipment. And that RCM will give you a set of libraries to give you the optimum preventive maintenance task. Preventive, predictive. We can look at condition-based. Yeah. Flange connection management. It's all about flanges. Flanges is the biggest source of leaks in an asset. So we look at specifically on how to make sure your maintenance activities related to flanges are properly conducted. And I'm here really talking about how to make sure the torque and tensioning of the bolts of the bolted flanges are tightening properly and the procedure is being followed. We do have a module called pipeline and subsea systems. Here you're going to look at ILI data, correlation of inline inspection data. You're You're going to run a fitness for service, a prediction of corrosion rate, mitigate the corrosion rate with inhibitors, for example. We're going to look at ACVG, DCVG, cathodic protection, anomaly management, remedial actions, a corrosion management framework. So there's a whole set of qualitative and quantitative tools within the pipeline module, yeah, that are specifically catered for that industry. We call IMS CIS. CIS, it covers the whole instrumentation life cycle, the safety life cycle, from a HAZOP to the LOPA to the SIF, to the calculating the seal level, optimizing or calculating the SIF, getting a test interval, optimizing the test interval, and creating a schedule out of your interval. So now, out of CIS, you will have like a test plan. When do I need to do a full functional test? When I need an overhaul test? And all the way to the checklist. How to use the protocols to record the test results of those that safety instrumentation. Civil structure, same as a mechanical integrity, but we're looking at civil structure like a pipe rack, a concrete foundation, and so on. A few other small modules like turnaround technologies, really looking at the process, fabric maintenance, looking at the coating and insulation. Different perspective, same approach of doing engineering, like a risk management, calculations, planning, and execution. Execution feedback into the planning. And we have HydroCore as part of the family that do, it's a theoretical methodology developed in laboratory to calculate and predict internal corrosion. Okay. So this is the framework that of disciplines we have within IMS. They can relate to each other. You can use RCM results or a seal level into your RCM analysis. You know, so all of them, that what becomes a one IMS. And that's when I say revolutionizing integrity management is how to use the different aspects into of an integrity management system into one approach. And we have to look at that into a framework like that we called it an asset integrity life cycle. What is that asset integrity life cycle? It is about starting from a foundational element. The foundational elements is really gathering your RBI data, right? You're looking at your risk-based inspection, look at probability of failure, consequence, what are the degradation mechanisms? But you can also look at an RCM analysis, is today a foundational element. Once you have that, you can start looking at an equipment care plan. An equipment care plan is a strategy focused on that unique equipment, looking at a specific degradation mechanism or failure mode, how that impacts that equipment, what do you need to do on that equipment to mitigate that failure. So that's an equipment care plan. And I think a lot of companies already do that, yeah. The system will spit out an inspection plan and you're going to execute, but that's based on an equipment. In IMS, we go a step further and we call that an asset care strategy. And a few fancy names around, but an asset care strategy is about combining multiple equipment care plans into an asset strategy. And say, okay, I do need to maintain that pump. That pump is connected to the pipe. That pipe is connected to a pressure vessel. If you have to do maintenance on the pump, maybe you want to anticipate and do some corrective work and some preventive work on the piping and on the vessel. And then you combine that and you really optimize that strategy. It is quite advanced. If you use that, you're really bringing your availability a level up. You bring your whole integrity management system. It is quite a challenge to make different disciplines to work together. But if you have a platform where the data is somehow harmonized and people are looking at the same set of data, the same hierarchy, the same database, it makes it much easier without having to interface different systems and so on. So that asset care strategy is really optimizing your individual plans. Once you plan, once you have any strategy, you're going to execute the task. And executing the task is all about quantifying data. I come from a time when an inspection was done using a piece of paper. Yeah, you get the board, you go in the field, you make some handwritten annotations, take some photos, come back to the office, download the photos, open a Word file and start entering the results and say, yeah, today was a sunny day and I went out in the field and I inspect these equipment. I did not find anything. These equipment had that anomaly. There was some checklist at the time, but still you have to go back to a Word document or an Excel file and fill that in. So today that execution of tasks is much more structured. You go in the field, collect the data, record that into a checklist. So now you take IMS, you go into the field, and you enter the checklist. The system will start triggering and start processing that. And we'll learn from those, and we'll trigger the process. Did I find a coding issue? Yeah, that coding issue will fit into my risk-based approach and say, okay, listen, your coding condition is not good. So you need to improve, you need to reduce your interval, or you need to take a corrective action. And you run that cycle again. That cycle you might run for an equipment, for a unit, for a group of equipment. That's an optimization. That's a live system. So that life cycle is an ongoing process. So it's not about doing an RBI assessment, create an inspection plan and executing that plan over the next 10 years. It's more about creating a plan, executing. You learn from it, update your studies, update your engineering calculations and come with a new plan. And that's all about IMS. It's all about process the data, create more data, integrate with other systems, and let the system work for you. I still believe that the equipment, because of the risk and the nature of this industry, you always need to keep inspecting. So the inspection will not go away. It's more about what are you looking for? How often are you looking for those? So that's the integrity life cycle that is reflected in IMS. But to achieve that, you need to go through a digital maturity. To do that integrity, to cover that integrity life cycle using a whiteboard, a piece of paper, and an Excel file, it's really painful. It's a very long exercise. There's it's scattered data. That's the problem I mentioned on my first slide. So companies need to progress, need to digitalize their process. And when I talk about digital maturity within CENOSCO, I'm talking about digitalizing your integrity workflows. So here in this chart, you're going to see the digital maturity level. So of course, the more you go to the right of that curve, the more mature you are. And the more mature you are, the more cost optimization you will achieve. And the more technical assurance you will get. Technical assurance, I mean by compliance. I mean by technically sound. Yeah. And then the safer you are. So it's a safety. Yeah, it's about integrity, reliability, but also the cost. So when you look at that evolution, you're looking at the pre-digital. Yeah, pre-digital is when you have a paper-based system. Even an Excel for me is a pre-digital. Yeah, an Excel, if you have a list of inspection plan in an Excel, and then you copy and paste the different lines and you adjust the columns, that's for me, it's a pre-digital. After the pre-digital, you go into a digitally reactive stage. That's where you recognize the problem, and then you recognize that this Excel file is not doing the job for you. So you react to that, and you will go into the market and buy an RBI tool. Pure RBI. I'm looking at 20 years ago. Yeah, the first software I looked at that was the T-Shook software that was pure RBI, just calculating the risk. Yeah, you would spit out some sort of interval, but it would stop, the process would stop there. It was very digitally reactive. The more you evolve, yeah, you become digitally purposeful. Purposeful means you recognize the value of the approach, and then you start looking at, rather than a specific application to solve a unique problem of one site, you look at the high level. What is the overall value that I get from those solutions? And then you start looking at, how can I record data? How can I start getting more and more data? How can I transform my report into data, into a checklist, into structured data? And then companies would start looking at the SaaS solutions. What is a SaaS? A SaaS is a software as a service. And a software as a service will evolve with the client. So you will get always the latest and greatest. So you're not looking at really going to a software boutique, building a specific software that suits your work process, but you go in the market and say, what is the best in the market? What is the latest technology that I can incorporate? And software is a technology, and it's constantly evolving. Yeah? Having a perpetual license do not exist anymore. Look at Teams, right? Every other month, when I look at Teams, it will give the Microsoft Teams, it will give me new features. Now it's giving me an advice. When I do a webinar, it will send me an email and say, hey, Luiz, you use a lot of filler words. You should have more pause between your sentences. You will get feedbacks. Yeah, but that's the evolution of the software. Every time you get more and more. Digitally integrated. I'm a firm believer that software, you will not have one software that solves all the problems. You still have different applications in your software portfolio, but the important thing in integrity management is that those systems will talk to each other. We are not, IMS and CENOSCO is not really here to replace a software like SAP. It has a huge value having a CMMS, and IMS don't want to take over that. But we want to connect with that. We don't want to replace a document management system. We want to integrate with that. A digital twin. A digital twin, we're going to bring all sorts of data from multiple applications, running simulations, focus on the process. Again, I don't want to take over that, but I want to use the 3D models, the isometrics, and I want to use that in IMS and share data. Share data. A digital twin will not have the sophisticated calculations and the algorithms that we have, but they will consume the outcome of a system like IMS. Then you're looking at a digitally strategic. Yeah, so here's the, like I say, the holy grail of an integrity management system, where you really start using the data that you capture, you correlate that data, and then you take a decision based on data. Yeah, based on data, say, okay, I have 200 pipes made of carbon steel that have this specific coating that is subject to that specific degradation mechanism that keep failing, that keep having a leak. And then you can drill down and say, how much piping is affected by that type of degradation? Are they well protected? And maybe you can start planning a campaign to replace that kind of piping, or look at the fabric maintenance for that pipe, and then you give, but that's data driven, right? It's not about an expert talking and having a feeling, it's about data. You can look at 3D risk, right? So traditionally the risk is going to be probability versus consequence, but what else can you correlate that risk? Yeah, can you correlate that risk with a certain level of confidence? Can you correlate that risk into to the actual condition of the asset? Although the risk is high, the condition, you know, make it better. So looking at a 3D risk matrix, that's data. Yeah, you're going to start looking at artificial intelligence and machine learning. And here I like to bring it an example. So CENOSCO is part of these open AI energy initiative that has been put together by Shell, Microsoft, C3, looking at using artificial intelligence for integrity management and maintenance in general. So the algorithm that we worked in that group was, can we fly a drone over the asset or walk around with the camera stick, taking millions of photos, and start looking at anomalies on those photos, right? The algorithm will look at the anomalies. Anomalies will be flagged in IMS. So IMS today has the capability of looking at that picture and mapping that picture to that 3D model, to that specific equipment in the hierarchy. A photo with an anomaly, there's zero value if you don't know which equipment is that. So here we're looking at an artificial intelligence with the core features of IMS. So that's the digitally strategic. So you will be able to bring the latest technologies much faster. So we do use some out. So we can call about an electronic corrosion engineer. Yeah. So we have some initiatives, as we call it, an ECE, an electronic corrosion engineer, that will start crunching a huge amount of data. Look at process. Will contextualize operation with many factors. Okay, so that's a digital framework, the digital maturity framework. That's how you're going to evolve on that. But how to get in there, you know, at which stage are you? Usually when I talk about this framework, users say, oh, I'm at that stage. Oh, I'm a pre-digital. Oh, I'm digitally reactive. But there's a path forward. And to show a little bit how you can come and implement that, you know, this is to show how IMS was built and how you can get that implemented. Yeah. So how do you implement IMS is CENOSCO will do a lot together with partners, like together with SGS, for example. So the interaction with the users, because it's an out-of-the-box application, you don't need to be involved to create templates, to create workflows, to create dashboards. A lot of that comes out of the box. So the involvement is being like, yeah, share your data with us. We're going to work. So the involvement of the user is minimum, all the way to the training and UAT. So there will be some interactions, but the most of the work is done by CENOSCO and SGS, for example, to bring that data to life. So when we turn on, when you have the user acceptance test, so you receive the final product, it's ready to use. Yeah. And what it comes with it, what IMS will give to the users at the end, it will give dashboards, right? Dashboard is a way to present data. A couple of dashboards, as an example, could be what we call a corrosion management framework, the one on the left. Yeah, so that corrosion management framework will give you the outcome of an inspection execution, right? And how that inspection finding is affecting a barrier or a safeguarding system and your degradation mechanism. So you can start crunching the data based on inspection result, based on the corrosion calculations. So your corrosion engineer, your RBI engineer would go into a dashboard and say, okay, those are my areas of concern. I need to take care of these group of equipment or those corrosion loops or that system, that functional system, because it has a lot of anomalies. My coating is really compromised. Oh, my process conditions have changed drastically. So I need to review my corrosion predictions. Yeah, the temperature has gone up. My calculated corrosion rate might go up. Right, so your remnant life will go down, your interval will go down, so you see a lot of effects will go, and IMS will give you all of that out of the box. IMS is all about dates and planning inspection and planning maintenance. So in IMS, if you're overdue, if you have an overdue, it means you're late. It means that you're carrying an excessive amount of risk. So that's the outcome. How you're going to manage, how you're going to, so those dashboards, the more zeros you have, the better it is. There will be dashboards tracking evolution and everything, but those dashboards are like a Power BI kind of tool. Looking at the technology, how do we work with the tool? We do have 3D models. We do have isometrics. So you can open a 3D model on your right, and open the isometric on the left and see where's the CML correlated. You can color code them and say, color code in red the CMLs with the high corrosion rate. So the system is bringing all these technology on board. When you're doing an RBI calculation, you can open the RBI, you can see the specifications, you can see inspection history, criticality, corrosion calculations from your wall thickness measurement, calculators from API, look at process condition, and getting a next inspection date, where you have a schedule, and that schedule has plan, has activity or tasks. So you relate the equipment to a risk program, to a schedule, and that schedule will have tasks that are related to that degradation mechanism, right? So your inspection plan is heavily based on data. IMS also brings a lot of features into barrier management. So in IMS, we do identify the degradation mechanism. We implement a barrier to prevent that degradation, to control that degradation, and then we implement indicators. How do we know that barriers are effective? Yeah, we know if the barrier is effective by using an IOW, right? If you have an exceedance, your barrier is compromised. If you do an inspection and you find corrosion, your barrier is compromised. You don't have any more corrosion allowance. And how we do that, how we feed that barrier management through interfaces with the PI service, but also looking at what we call an equipment condition history. That equipment condition history will have checklists, and those checklists will give you what good looks like. So you take a procedure to the field and say, okay, which kind of corrosion do I have? What is the condition of my site? And if you find an anomaly, you'll be able to create a corrective action. Yeah. So that corrective action will go to your SAP. Yeah, the corrective action, you will start planning, fixing that. There are advanced corrosion calculations, always looking at prediction, look at historical wall thickness measurement, and how that will behave. And then you can look at, if you have a piping system, a pressure vessel, you can compare different types of corrosion rate per equipment type, trending, yeah, the whole statistical part of it. An important thing is that we do support import Excel files. So throughout the whole application, if you want to update data in bulk, you can always export for import, right? So when you export for import, you export, change the data in Excel, and then import that back again. We do have a separate different templates. If you want to migrate data, everything is done out of the box from the user interface. So you can import a single file, you can import multiple files at the same time, you can import a file with multiple tabs. So it's a very advanced feature to export for import that data. And finally, I think you guys got my point. I could go on and on, explore multiple examples covering mechanical integrity, rotating equipment, safety instrumentation, pipeline. The approach would be the same: engineering calculation, risk management, inspection planning, inspection and maintenance execution, and the corrosion management framework, how we can correlate. And we have specific tools we call a managed equipment care that will look at the optimization, the asset care strategy. Yeah. So now you understand, or at least to the minimum, what IMS is capable of as an application. It's really a market standard. Yeah? It's been used for a lot of oil majors, Shell backing up the whole development for the last 20 years. But that's a journey, right? You will not get a very mature from day one. But CENOSCO and SGS can help, can work with you to get that implemented. And some of the examples that we work together as that, with the lever that the out-of-the-box template, right? So it's an out-of-the-box application. You get a lot out of the box without any configuration or customization. With SGS, you will get the studies and the consultancy for implementation. We work together with the training, right? Train the trainer, whatever we implement. Then we have an engineer that will go on site, train and qualify the people. We're going to migrate the data. Yeah. The guys from SGS can digitalize and create 3D models, create isometrics. Yeah. So you need to have those to go towards that digitalization, visualization of data. And of course, SGS will help you with collecting data in the field during the RBI study, for example, or during any kind of RCM study, but also conducting, the field inspection, updating your RBI analysis, the audit checkup and everything. That list is not exhaustive. There's a lot of other things that we've been working together in the past. That was my story. I keep looking at the clock here. I've already eaten all the time I've allocated, and now I would like to get some time to ask Saim to help me to get some of the questions and answers. Saim?
Yes,
Yes,
hello.
thank you, Mr. Luiz.
So you hear me?
Yes, Saim.
So
No, Saim, your
starting
voice is
from
not.
our chat box, we get a question about the data quality, that how much mature data of anyone industry required for encounter the problem of data unavailability in some cases. how such problem can address. I think this answer is just as per we are doing the study, we have the option of assumptions as per best industrial practices. And furthermore, if Mr. Luis, you want to add some point on that question.
Yeah, so data quality and data quantification, we do have actually specific dashboards and queries that will look at that, right? So we can flag the quality of the data and the quantity of the data that's been uploaded into IMS. So there are, when you're implementing an RBI study for a site, you don't expect to have a very complete set of data for all the units. And the methodology that we have in IMS.
Another question we received about the implementation of engineered building as well. I think this is related to our digital twinning option for integrity management.
Yeah, so we do integrate with the digital twin, like from Aviva, from SDX, and Cognitwin. We do integrate. We do have a specific methodology for civil engineering, right? Where we look at the specific failure modes for civil constructions, for concrete, for example. So that's part of the whole overarching integrity management system. Yeah. But you can visualize the 3D models and everything in IMS.
Okay. Another question is about if we have already an RBI or asset integrity program. So what are our options to load our data in bulk form in this current CENOSCO IMS?
Yeah. So IMS will have, like I've shown before, we do have specific templates to import RBI, and we do have already templates. So you can basically get the data from, let's say, Capstone, right? The old software from Capstone. You can extract that Excel file and then import in IMS directly. If you respect the template, it's very easy. But during the implementation of IMS, CENOSCO will take care of that. All right, but it is possible. Absolutely.
So another question we have, Mr. Luiz, that about the KPIs related to our IMS program. So we have any visual dashboard for that? That we have that much we have planned that these equipment should be inspected and maintain this frequency and this intervals. So the question is about we have the KPIs dashboard like something.
Yeah, there's a lot of dashboards. We do have a lot of KPIs. They're like compliance KPIs, for example, that we're going to look at overdues, overdues per equipment class, per equipment risk. So any correlation, any KPIs. There's a compliance dashboard with 150 KPIs out of the box that were gathered over the last 20 years. So those KPIs are embedded. It's part of the work process, and it's within the concept of out of the box deploy. Yeah, absolutely. I love those KPIs. And we will also trend, how are you going based on that KPI month after month. Yeah, a full set of KPIs on that.
Another question is that we can upload our relevant documents. I think it is part of presentation also that do we have, for example, if we are focusing on equipment and we want to view its manufacturing drawing or manufacturing data sheet, GA drawing and Excel data for that. So we have that option in this software.
Absolutely. You can import the drawings into the IMS database, or you can interface IMS with your SharePoint, for example, or your library of documents or your document management system like Qazi. We can integrate that, so we receive always the latest version of the drawing. So whenever you open your, let's say, equipment page you will see that 3D drawing and have that correlation with the isometric. Absolutely. That's fully part of IMS. You can bring that 3D model in IMS, or you can interface that. You see the isometric on the left. It's fully available. You can make annotation in the field and so on.
We receive another question that is this software provide the semi-quantitative RBA study related to our RBA module, or the qualitative, or both?
It goes the qualitative, right, where you just indicate what is the probability of failure and consequence. It can go to a semi-quantitative. So there are specific ways of asking the question. You can say, oh, my consequence is 1 million. Yeah. But you can say, okay, my consequence is split up like that. Or you can go a full API 581 calculation on the consequence. The same for the probability. You can base that on your know-how, or you can base that on the API 581 algorithm. So you can use any combination of that.
So, question regarding KPIs, that as you explained that we have 150 KPIs can update it of management. So we can alter them as our requirement as per company policies.
Absolutely, absolutely. The KPIs and the dashboards and the queries, you can build them from the user interface. So if you have a good people that understand the logic of those queries and is good in Excel, basically do some coding, it's easier for them. So you can create your own KPIs, correlate data, create dashboards, pivot tables, everything in IMS from the user interface. We will give you all the training and the manuals on how to do that. Yeah, out of the box. That's a very good capability.
I think some participants are raising hands. We have this option to ask questions in chat box. You can type your message there. So we can.
Yes, Mr. Wasim Khan, you can just write down your question. So we'll definitely, our speaker, our moderator will answer the question. Presentation, we cannot share on email. This webinar recording will be available on CENOSCO website, so you can just go through that, Mr. Nisana.
If you want to go into more details or in depth on specific elements of this presentation, or how would that apply to your organization and the methodology and the process you have, of course, feel free to contact either SGS or CENOSCO, and we will help you.
Okay, Wasim Khan has a question. What about the corrosion prediction model in CENOSCO software?
Yeah, so the corrosion prediction models, we do have statistical models we call SIDAP. It's a specific model to predict the next inspection date based on corrosion rate of that specific piping and so on. We do have that. We do the basic calculation, like the long corrosion rate, short corrosion rate. And we do have a specific, we bring the calculations from API 581, and we do have some proprietary calculations like the extreme value analysis for heat exchanger bundles. We do internal corrosion prediction for carbon steel pipelines as well, using a methodology that's called hydrocore, that use a specific laboratory methodology. But yeah, we do have a number of different corrosion predictions based on the equipment type, the material, and the service.
Thank you, Mr. Luiz. We have another question. We'll just take 2 more questions. And this is from Murtaza Ali. Can you please let us know where this IMS is in use, especially for oil and gas industry?
Yeah, absolutely. I mean, integrity management and RBI, it was born in the oil and gas, right? So it's heavily geared towards oil and gas, chemicals, fertilizer. We are expanding into pulp and paper, energy, but the core, the biggest value you get out of IMS is when you get the libraries that are related to oil and gas. Yes, we are kind of oil addicted, but it's mainly oil, gas, and chemicals. Chemicals would include also like fertilizers, if you want. Yeah, absolutely. That's our ideal customer profile: refinery, oil and gas, medium size.
Yes, thank you. We have another question from Mr. Zahir Ahmed. He's from Parco. What customization of dashboard we can do?
Customization is you will get, users get an out of the box, I don't know, 20 dashboards with different queries, but you can create a dashboard exactly the way you want, right? There's no limitation whatsoever. If the data is an IMS, you can get a dashboard out of it. That configuration of the dashboard you can leave to CENOSCO to do, or we can teach you how to do it yourself. It looks like Power BI, right? The same philosophy, yeah, but it's updated with the data in IMS.
Okay, is it linked with the SAP S4 HANA, and what is change it does?
Yeah.
Yeah.
So IMS is fully integrated with SAP. We can integrate with SAP, Maximo, or EAM. What we do with that integration is that we make sure the asset hierarchy is aligned, right? So whatever the equipment you have in SAP is also reflected in IMS. Yeah. So we have that hierarchy aligned. So you make sure that you don't have any equipment that is not inspected. So there's a whole methodology workflow to make sure we're not forgetting about any equipment. So once the hierarchy is aligned, you can then create a notification and a work order in IMS and push that into SAP. Yeah, so you can say the inspector goes in the field, he finds an anomaly, he creates a corrective action, and that corrective action goes into SAP. Yeah, as for HANA, yeah, Blueprint, there's all the flavors, it is fully covered. And I think SAP is the most common CMMS application for the oil and gas. Yeah, so yes, fully compliant with that.
Thank you, Mr. Luiz. This is the last question we are taking. Could you show the consequences analysis by indirect method in CENOSCO software?
Yeah, I think we can talk that at a different occasion. But yeah, so the software will do the calculation. There's three types of consequence assessment, like simple, direct, simple, and detailed. So the more detailed, the more data you need to look at. So you can look at release rates, and you can look at the area calculation. So there's a lot of calculators involved. All of that is in a very user-friendly way. They can be updated in bulk, can be exported for import. Yeah. So if needed, we can take it separately, and I can give you more in-depth detail about the methodologies that we cover in IMS.
Okay, the last one is your RBI is quantitative.
Yeah, we do. So the core methodology that IMS have today is we call SRBI. The S stands for Shell, so it's a Shell RBI methodology. That is, it can be a qualitative to semi-quantitative. So it does have a lot of the calculations embedded. But we are working actually together with SGS in Pakistan to release the API 581 compliant module that will come in the next coming months. So today it is up to semi-quantitative, but we will have in the near future the fully quantitative approach. We have written a blog post about the quantitative versus qualitative approach in RBI. So if you're more interested, it's a subject that I like. Take a look on CENOSCO website. We have written a blog post on that. What are the benefits and advantages and disadvantages of each of these methodologies?
So we
Thank
have
you.
the
Yes.
calculators of 580 calculation in this current software.
We do.
So we can.
Thank you, everybody. Thank you, Mr. Luiz. Mr. Zahir Ahmad, we can take your questions. You can send us your email, so we will be definitely answering your question. Same for Mr. Wasim Khan, Mr. Zahir Ahmad. Thank you, everybody, for sending us your questions. Mr. Luiz, thank you very much for giving us presentation on this much needed topic regarding IMS software. Thank you, Mr. Saim Qazi, and thank you everyone for joining. Have a good day. Thank you and goodbye.
Thank you. Have a good day.
Thank you.
Thank you. Thank you, everyone.
Thank you.